guest speakers could just come forward. We're going to do a Q&A session. If our guest speakers could come up. And I'm going to kick this off with a question. If Curiosity were to find some sort of evidence that life had existed on Mars, what do you think that evidence would be or look like?
The best chance that Curiosity has for finding something directly relevant to the search for life on Mars is finding organic material with the SAM instrument. And as I said, I was hopeful that in that gray stuff we would find Martian organic material, and we haven't yet. It may still be there at very low levels, and we may be able to tease it out from the data, but it's not there in very strong amounts, as in the amounts that we expected, just due to meteorites. So to my mind, that's the key step. Once we find organics, that gives us something to search through and search for evidence of life. Other questions? Anybody have any questions? Question?
You mentioned that you wanted to drill down a meter or more to possibly find those organics because of radiation. What type of gauge, how long does it take the radiation to affect distance down?
That's a really good question. The question is, how deep, and does it matter on how old the material is? The Yellowknife Bay formation that we drilled into was probably put down a long time ago, but it's probably been exposed fairly recently. So its radiation age may not be that long. So we're not sure how deep the radiation has penetrated and destroyed organics, and this relationship between depth and time. But there's another factor that seems to be amplifying the effect of radiation on Mars, and that's perchlorate, the chlorine chemistry. There's one thing that might be occurring to you is we have meteorites in space exposed to radiation, and they're rich in organics. One of them fell in Sacramento last year, and their organics aren't destroyed. Why are they being destroyed on Mars by radiation? So there's things that we don't really understand, and in fact the SAM data and the Curiosity data might help us understand it and come up with a quantitative answer to that question. Depth, time, relationships for exposure, and the particularities about Mars, which seems to be amplifying the destruction of organics compared to just radiation alone, which is what the meteorites experience. Now my guess is that Martian amplification is due to chlorine and water reacting, driven by radiation, creating the perchlorate that we were so surprised to find on Phoenix and surprised to find in the gray stuff at Yellowknife Bay as well. We don't really understand how that forms. In fact, we're doing experiments in the lab to try to simulate it. Other questions? Maria?
I have a question. How likely is it that there could be water flowing deep underground on Mars? And if so, what kind of instrument would we have to land to find it?
Well, deep underground, people have speculated, particularly Stephen Clifford in Houston, has speculated that there could be deep liquid water reservoirs. Obviously, when we have drills that can go an inch, we're not going to drill down to them anytime soon. But there is a chance to see them with radar. And in fact, Mars Reconnaissance Orbiter and the European Mars Express mission both carry ground-penetrating radar that in principle could detect liquid water in the subsurface, because liquid water has a very distinct electric dielectric constant that is very different from ice or soil or rock. And so water shows up on radar very clearly. So far they have not discovered any subsurface liquid water reservoirs. I think it'd be premature to rule them out, but we have not found them yet with the two radars in orbit. Yeah.
I was, during the broadcast they mentioned that 1 ton was about the limit of what we can land on Mars right now. And I know that part of that is like heat shield limitations. And I've been learning a little bit lately about the Dutch concept. I was wondering if you could talk about what NASA Ames is doing to enable us to land bigger things.
Yeah, that's a very good question. That's what a lot of us are working on. There is ways you could land bigger objects. So the question is, this is the limit of the current entry, descent, and landing technologies, landing about 1 ton on the surface of Mars. How big can we go, and how do we plan to go there? For human missions, you would probably need about tens of metric tons, about 30 or 40 metric tons each time. You cannot just keep growing the size of the vehicle because our launch systems cannot take any bigger vehicles on them. You have to have a technology that creates the drag. The problem with landing bigger things is you've got to slow down fast. You're coming down with a lot of energy, a lot of heavy weight behind you. How do you slow down without getting bigger? The concept that NASA is looking at is deploying something while you, so that's a DAP concept that you talked about, is essentially deploying a drag device, so opening up, it's like an umbrella. There are other concepts that are inflated, so you have gas generators that will inflate a big device around you that kind of slows you down fast enough. So for those technologies to work, and these devices, of course, are going to get hot. And you can imagine building a balloon that can get hot, 1,000 degrees. So you have to develop some more protection system for these flexible devices. So that's what we are working on, developing this big mechanically or inflatable devices with thermal protection on them.
Any other questions? Thank you very much, everyone, for coming out here today. I really appreciate it. And thank you to our 4 speakers. Thank you very much for coming out today.
And we'll see you on the 2-year anniversary.